Hair is so soft, it's unbelievable. Senior pictures tonight, amazing, go well. So take out your notes. I don't know. I sent one in. What? What's up? Okay, here we go. Continuity. Continuity is an extremely important part of calculus. The ideas of calculus were first developed around 200 BC. Archimedes, one of the great minds to ever walk the face of the earth. Some people say the greatest. He had formalized the ideas of calculus. They were excellent, but they weren't fully kind of provable mathematically. It wasn't until the 1600s that we had that. And a guy by the name of Isaac Newton and Leibniz, they did a good job of laying the foundation. Limits and continuity provide the foundation for calculus to work. Here's the idea of continuity. We would say that this is a continuous graph. We would say this is a discontinuous graph. We would say this is a discontinuous graph. We would say this is a discontinuous graph. We would say that this is a continuous graph. Talk with your peers, try and come up with a definition of what is continuous and what is discontinuous. Go, talk. Okay, somebody, quick definition, continuous, Patty. So, thou shalt not use the word in the definition when providing the definition, right? Well, yeah, it's like rule number one. Yo.
It's a line that does not break off.
A line that doesn't break off. Definitely not a line, more of a curve, huh? What do we got? If you could draw the graph without picking up your pencil, it's continuous. That's the very non-mathematical representation of a continuous graph. If you could draw it without picking up your pencil, it's continuous. But we need to lay the foundation more mathematically, and here's how it goes. A function is said to be continuous at a number a if the limit as x goes to a of f of x is equal to f of a. Now the problem is that is mathematically correct. It's beautiful, but we don't know what the heck it means, does it? So let's teach you what it means. There's really a three-step criteria we go through in order to determine if a function is continuous. Rule number one is this: f of a exists. That means that there's a spot on the graph at that point. Okay? That means that there's actually a location. Number two is the limit as x approaches a of f of x exists. So the limit must exist. If there's no limit, if the limit does not exist, it's definitely discontinuous. Really quick, up here, I want you to try to draw a graph where the limit does not exist, and try to show your partner a graph of a limit that does not exist. See if you can do that. Go, take about 30 seconds. Great. I saw somebody draw this picture, okay? So let's check it out. Would everybody agree that that's a discontinuous graph? Yeah. And would you also agree that the limit does not exist at this spot? Yeah. But when you plug in this value, let's say it's 1, f of 1, there is an output, isn't there? So in that case, number 1 is good. Like f of a does exist. This is discontinuous though because it fails number 2. And finally, number 3 is that number 1 and 2 have to be the same. Or in other words, the limit as x goes to a of f of x must be the same as f of a, which is what we wrote at the very beginning. So let's make sense of this. We are going to look at the spots where this graph is discontinuous, and we're going to identify why. Quick, I want you to write down the numbers on the side, the x values where this is discontinuous. Go. Write down where it's discontinuous. Where is it discontinuous? Where do you have to pick up your pencil when you draw it? Where does it have a gap? Draw it down. X equals what? At what spots is this graph here discontinuous? Write it down. Anywhere. Right here. Right off to the side. Nope. It's definitely continuous at -4. Definitely continuous at -3. Definitely continuous at -2. At -1. At 0. Oh, it's discontinuous at 1.
So when you're circling this, are you circling it on the x?
Yeah, the x values. And stop. I have 3 spots where this is discontinuous. As I draw the graph, notice I have to pick up my pen when I get to that spot. So for an x value of -5, I have to pick up my pen when I get to that spot, which is at 1, and I have to pick up my pen again when I get to 4. Is everybody okay that those are my 3 spots where the function is discontinuous? Okay, I want to work from 4. I want to work from left or from right to left instead of left to right. Okay, so this is the part where you have to think. Most people know how to identify where it's discontinuous, but which one it fails to meet, this is where you really have to think in. Okay, so focus here. First criteria. Let's start with number 4. Does f of 4 exist? If you plug in 4, do you get an output? No. There's no circle there. There's no circle anywhere on 4. Okay? So therefore, it fails number 1. It fails number 1. It fails because f of 4 does not exist. Everybody okay with that? All right. Let's move along. We're going to move to number 1. Does f of 1 exist? If you plug in 1, do you get an output? Yeah. What is it? 6. So that works. Everybody good? Yeah. Let's check the second one. Let's see if the limit exists. I'm going to approach from the left. I'm going to approach from the right. Are those two the same? No. So the limit does not exist. So this fails number 2. All right, limit does not exist, okay? And here I'll write f of 4 does not exist. All right, let's check number 5, or -5, okay? Does f of -5 exist? What is it? It's 3. Everybody agreed? So I check it off. That works. Good. I look at the second one. I got to check the limit. Limit from the left, limit from the right. 7. So that works, doesn't it? Okay. Are those two the same? Is 7 the same as 3? No. So therefore it fails number 3. I heard a question. If it's discontinuous, it will always fail one of these. And if it's discontinuous, it will always fail number 3. But we do it in order. Do you understand? So sometimes on the test, people get smart with me and they say, anytime I say, tell me the reason why it fails, I say, fails number 3. Yeah, but did it fail this one first? You need to go in order. Do you understand? Otherwise, people just fails number 3, fails number 3, fails number 3. Haha, Mr. Gens, I got it right. You got it wrong. You're a loser. I'm smart. Okay, nope, don't like that. Go in order. Everybody clear? All right, here we go. No. What? Here we go. Explain why the function is discontinuous at this given value here, and sketch the graph of the function. So I'm going to tell you right now that this function is discontinuous at 2. See if you can talk with your partner for 30 seconds to see how you could have known as well that this is for sure discontinuous at 2. Talk. Go. Yeah, very good. So if you look at this graph, you can see if you were to plug in 2, you get 0 in the denominator. What do you get in the numerator as well? 0. You also get 0 in the numerator. And we learned that you can take 0 divided by 0 and get it figured out, can't you? Let's look at the graph. So I'll show you how to figure out what this graph looks like without using your calculator, but I like to go to my calculator right now because I think that that's what a lot of you guys would do. I'm going to go to y equals, I'll type in x squared minus 4. Do I have to have that in parentheses? Yep. Got to have the whole numerator in parentheses. divided by parentheses x minus 2. Whoop. And I'm going to zoom 6. And what does the shape look like? Tell me more. Tell me more about a line. What else? What kind of line? Line with a slope of 1 passes through a y-intercept of? Everybody agree that that looks like x plus 2? Watch. If I take the top and I factor it to x minus 2 times x plus 2, and then the bottom I have x minus 2, you can see that it wants to look like x plus 2. Agreed? But we know it's discontinuous somewhere, and I can see if I zoom as a decimal number 4, you can see it has a gap. Oh, it's missing right up there. I'll try to zoom out, see if I can see it. Number 3. Come on. Work for me, please. Oh, there it is. See at number 2? See it has a gap right there? So here's what it looks like. 1, 2, 1, 2, 1, 2. Right there. Very good. That's what the graph looks like. I drew a graph of x plus 2. We could see why it was going to look like x plus 2. Is everybody okay with that? But we knew it had a hole at 2. Okay? Anybody know the y value of that gap right there? 4. Because if you plug in 2, you get 4. See that? We all got it? But does everybody agree that this graph is discontinuous? Yeah. All right, let's figure out which of the 3 it fails to meet. You guys talk and decide which of the 3 it fails to meet. 5, 4, 3, 2, 1. Does it fail number 1? Yeah. Yes. Does it fail number 2? No. What is number 2? The limit. The limit needs to exist. As you can see here, the limit does exist, doesn't it? The limit's 4. Everybody agreed? Yeah. So it definitely fails number 1. If you plug in 2, you do not get an output, okay? And so you just write fails number 1. You could write that, or you could write f of 2 does not exist. Either one is fine. These mean the same thing. Everybody okay with that? So you need to be able to generate graphs. You can use your graphing technology to do so, but then you have to identify the reason why it fails to meet that. Let's look at the next one. What do you call this kind of function? Piecewise. What does the graph of x plus 1 look like? Good. What does the square root of x look like? Okay, so let's draw those graphs. I'm going to plug in 0, and when you plug in 0, what do you get? 1. Open circle or closed circle? Open circle, and I'm going to draw a graph of x plus 1. I'm just going to draw the left side. We all see how I did that? Do you understand now why we've been practicing piecewise functions? Okay, so that when they come up, we don't have to spend 15 minutes trying to figure it out. All right, plug in 0 here. Square root of 0? 0. Open or closed circle? Closed. That's my graph of the piecewise function. Talk to your partners. Does this fail to meet 1, 2, or 3? Go talk. Okay, 5, 4, 3, 2, 1. Does it fail number 1? No. No, because f of 0 exists. F of 0 is 0. Does it fail number 2? Yeah, the limit does not exist, okay? Because the limit from the left is 1. The limit from the right is 0. So it fails number 2. We all got that? Any questions? Going once, twice, thrice. Okay, take out your homework. We're going to turn this from a 1-day lesson into a 2-day lesson so you guys can have some practice on it. I'm not judging. No judgment. No judgment. Okay. Look at that.
That's the best. That's the best. I got 2.3 now.
Okay, you guys can handle problems 1 through 7 right now. Problems 8 and 9 and 10 and 11, that's something we'll look at tomorrow. I'd like to look at problem 6 with you right now if you turn to that. It says f of x is equal to 1 over x minus 1 for x not equal to 1. And then it says that f of x is equal to 2 when x is equal to 1. And you're supposed to identify which of the 3 criteria. Identify which of the 3 criteria the continuity fails to meet for a equals 1. Here's what I want you to do. See if you can start by just sketching the graph. Sketch the graph. Go. Five, 4, 3, 2, 1. Eyes up here, okay? You should see that the parent function, I'll draw it in green, the parent function looks like this. Okay, so what we're doing is we're shifting it to the right. How many units? 1. So what you want to do is you want to take that same shape and you want to shift it to the right 1 unit. So I'm going to make that asymptote go here, and it's going to go like that. Any questions about that so far? Going once, twice, thrice. Now it says when x is 1, have a value of 2. What does that look like graphically? A point of 1, 2. So I'm going to go ahead and graph this, and I'm going to go 1, 2. So I've got this dot filled in right there. Talk with your peers. 20 seconds. Does it fail to meet 1, 2, or 3? Go. Talk. Five, 4, 3, 2, 1. Does it fail to meet number 1? Does f of 1 exist? Yes, f of 1 exists. Does the limit exist? No, because the limit from the left is negative infinity. The limit from the right is positive infinity. Now, suppose the graph was different. Suppose the graph looked like this. Suppose it said x minus 1, it was x minus 1 squared, and so that would create the red graph, and then I have this dot right there. Now, decide, we know it's discontinuous because I pick up my pencil to draw it, right? But does this fail to meet 1, 2, or 3? Talk. Go. 5, 4, 3, 2, 1. Does it meet number 1? It does, because f of 1 exists. It's 2. Does it meet number 2? Yes, it does. What is the limit? The limit is infinity. So the limit is infinity, so it satisfies number 2. Is 2 the same as infinity? No, so therefore it fails number 3. Jack and Tim, can you tell us why you thought what you thought? Okay, they're blaming each other, pointing back and forth. Criteria number 2 is what? The limit must exist, right? Does the limit exist? Yes. You guys can try problems 1 through 7. We move on the rest tomorrow. Go. You got about 10 minutes to work or so. 15 minutes. Go.